It started as a whisper across the cosmos, faint, rhythmic, and oddly persistent. At first, astronomers thought it was just another blip in the background noise of the universe. But this signal didn't fade. It repeated, it pulsed. And then, it grew stronger. Coming from a distant star thousands of light-years away, the signal wasn't just unusual, it was unlike anything we've ever recorded. No known star should behave like this. It emits a pattern so precise, so deliberate, that it's forcing scientists to question everything they thought they knew about stellar physics. Could this be a natural phenomenon we simply don't understand yet? Or is it something far more mysterious, perhaps even artificial? In this video, we'll explore the origin of this strange cosmic transmission, the bizarre characteristics that make it so unique, the theories that are currently on the table, from magnetic anomalies to alien technology, and what it could mean for the future of astrophysics. Buckle up. This might just change the way we see the universe. The star in question is located deep in the Milky Way, in a region far beyond the reach of our naked eyes, about 15,000 light-years from Earth, in the constellation of Vulpecula. It's known by its catalog name, VFTS 243. To most people, that's just a string of letters and numbers, but to astronomers, it's becoming one of the most talked-about stars in recent memory. Classified as a massive blue giant, VFTS 243 is at least 25 times the mass of our Sun and burns with an intensity that could outshine entire star systems. Normally, a star like this lives fast and dies young, going supernova in just a few million years. But this one has decided to throw us a curveball. For decades, it was just another entry in the star charts. Bright, powerful, and relatively stable. But then came the signal. A repeating radio burst with a cycle so mathematically precise, it immediately raised red flags. This wasn't some chaotic burst of solar wind or magnetic interference. It was structured, timed, and consistent. It didn't match any known stellar activity, not from pulsars, magnetars, or even fast radio bursts. What made it even more bizarre was that the signal only began recently, as if the star had suddenly awakened, or been switched on. Astronomers around the world scrambled to verify the data. Telescopes in Chile, Hawaii, and even orbiting satellites turned their gaze toward VFTS 243. What they found was unprecedented, a cosmic transmission that seemed to be whispering a secret no one could yet decode. To understand what might be happening, with VFTS 243, we have to dive into the life of a star, because stars, like all living things, have a beginning, middle, and end. Massive stars like this one are born in clouds of gas and dust, collapsing under their own gravity until the pressure in their core ignites nuclear fusion. That's the process where hydrogen atoms are fused into helium, releasing incredible amounts of energy. This energy pushes outward, balancing the gravitational force trying to crush the star inwards. It's a delicate tug-of-war, and for millions of years it holds steady. But over time, the fuel begins to run out. The star grows unstable. It starts fusing heavier elements, helium into carbon, carbon into oxygen, climbing the periodic table, until it hits iron. That's where the process breaks down. Fusing iron doesn't produce energy. It absorbs it. When the core fills with iron, fusion stops, gravity wins, and the star begins to collapse in on itself. That collapse happens in mere seconds, triggering a cataclysmic supernova, one of the most violent events in the universe. Now here's where it gets interesting. The signal coming from VFTS 243 has characteristics that some scientists believe could indicate it's entering this final stage. The repeating pulses may be tied to internal instabilities, shifts in the star's magnetic field, sudden changes in its rotation, or even material collapsing toward the core. These aren't just guesses. Instruments like the Hubble Space Telescope And the European Southern Observatory's Very Large Telescope have picked up subtle fluctuations in brightness and temperature. Neutrino detectors on Earth, designed to spot nearly massless particles from deep space, have also picked up slight increases, possibly early warnings of core activity intensifying. Some astrophysicists suggest we could be witnessing the last breath of this massive star. Others think we might be seeing the birth of something entirely new, like the formation of a black hole in real time. The problem is, no one's ever seen a star emit this kind of precise repeating signal right before death, and that's what has the scientific community on edge. Something's happening inside VFTS 243, and it's not following the rules we thought we knew. Here's the mind-bending part. Whatever is happening inside VFTS 243 might have already happened centuries ago. Because the star is 15,000 light-years away, the signal we're receiving now actually left the star during the time ancient civilizations were building their first cities. We're looking into the deep past, watching the light of a star's ancient heartbeat, and trying to predict what could already be finished. If VFTS 243 is truly on the brink of a supernova, that explosion may have occurred long ago. We're just waiting for the final flash of light to reach us. But if it hasn't exploded yet, we could be on the edge of witnessing a once-in-a-lifetime event. Some astronomers believe we might see the end of this star within our lifetimes, or even within the next few years. Others are more cautious, suggesting it could still be decades away. Still, the signal's sudden appearance and intensity have many wondering whether the countdown has already begun. And if it does explode, it will be breathtaking. Supernovae from massive stars like this can briefly outshine entire galaxies. VFTS 243 could become as bright as a full moon, visible in the daytime sky for weeks. Imagine looking up and seeing a new star so luminous it casts shadows at night. It's the kind of event that ancient people would have recorded in myth and legend. And we, in the 21st century, might be next in line to witness it. Imagine stepping outside on an ordinary evening, only to see a brilliant new light piercing the night sky, so intense it rivals the full moon. No telescope needed, no special equipment. Just look up, and there it is, a cosmic beacon glowing with the power of a dying giant. If VFTS 243 goes supernova, the explosion would unleash a burst of energy so vast it would momentarily outshine everything else in the galaxy. For weeks, maybe even months, it would remain visible to the naked eye, even during daylight. At night, it could cast shadows on the ground. It might shimmer in hues of blue and white, flickering like a flame in the sky. Across continents, people would gather to watch, to wonder, to feel the enormity of what they're witnessing. In cities and remote villages alike, it would become a global event, shared across social media, news headlines, and whispered conversations under the stars. This wouldn't just be a scientific milestone, it would be a deeply human one. For most of us, it would be the first, and likely only time we ever witness a supernova with our own eyes. A real cosmic transformation playing out live in the heavens. It's the kind of moment that reminds us just how vast the universe is, and how connected we are to the stars that burn and die light years away. The explosion of a star like VFTS 243 wouldn't just be a stunning sight, it would be a scientific goldmine. Quite literally, when a massive star goes supernova, it becomes a forge unlike anything else in the universe. In those final moments, when the core collapses and rebounds, with unimaginable force, elements are created that didn't exist before. Gold, platinum, uranium, and dozens of others. These aren't formed in the quiet burning of stars, they're born in chaos, in the violent crucible of stellar death. This is cosmic recycling on the grandest scale. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was created in ancient stars that lived and died long before our sun was born. Supernovae are the universe's way of scattering the ingredients for life across space. Without them, planets like Earth and life itself simply wouldn't exist. Studying VFTS 243 as it nears the end of its life gives scientists a front-row seat to that process. It's a rare chance to understand how stars evolve, how elements are formed, and how black holes, or neutron stars, are born. Other massive stars like Antares or VY Canis Majoris may follow similar paths, but none have given us a signal quite like this. If VFTS 243 is truly preparing to explode, we may be witnessing not just the end of a star, but the beginning of a new scientific era. One where we better understand our origins and just how much of us comes from the hearts of stars. As dramatic as a supernova sounds, rest assured, Earth is perfectly safe. VFTS 243 is about 15,000 light-years away, far beyond the distance needed to cause any harm to our planet. Even in its most explosive moment, the radiation and debris from this star won't come close to touching us. What we'll witness is all light and wonder, no danger involved. There might be some fascinating atmospheric side effects, though. A bright enough supernova could slightly increase ionization in the upper atmosphere, potentially leading to more vivid auroras near the poles. But these changes would be harmless, more a cosmic show than a threat. And thanks to modern technology, we may even get a heads up before the light from the explosion reaches us. Neutrino detectors buried deep beneath Earth's surface are tuned to catch nearly massless particles that race ahead of the light. If the star collapses, these detectors could give astronomers a few hours' notice before the bright flash appears in the sky, like a cosmic early warning system. So, if VFTS 243 does explode, we'll be ready, not just to watch, but to learn. We're witnessing the final breath of a giant, a farewell millions of years in the making. VFTS 243 has burned for eons, lived through cosmic cycles we can scarcely comprehend, and now it may be preparing for its final, spectacular act. Somewhere deep in the fabric of space, a signal has begun to whisper across time, and we're lucky enough to be listening. Moments like these remind us just how ancient and vast the universe truly is. The light from this star began its journey before we ever discovered fire, before we built cities or dreamed of reaching the stars. And yet, here we are, watching, wondering, connected across millennia by a beam of starlight. It's easy to feel small in the face of such grandeur, but it's also comforting to know we're part of it. Every atom in our bodies was born in stars like VFTS 243. We are, quite literally, made of this cosmic story. So, keep looking up. The sky isn't just a backdrop to our lives, it's alive, with motion, mystery, and messages waiting to be uncovered. Somewhere out there, another star may be sending its final signal right now. And one day, if we're listening, we'll hear it. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think about the mysteries hiding in our universe.